Problem number 5 says solve each quadratic equation using the specified method. So part A wants us to use a quadratic formula for the equation 0 equals 3x squared plus 4x minus 7. Let's start by labeling A, B, and C. Remember that when you have an equation in standard form, that is when it's in the form ax squared plus bx plus c, this number in front of the x squared is our a, this is b, and this is c. So in this case, a is equal to 3, b is equal to 4, and c is equal to negative 7. We include that negative sign in front of it. How does this help us? The formula is, I'm going to sing it, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And now that we have this formula, we can start plugging in a, b, and c and then simplify. So we're going to plug in a here and here. I'm going to plug in 4 for b here. Oops. And there, and then finally plug in C. All right, simplify. So we've got negative 4 out front, plus or minus. If we want to simplify this 4 squared, well, that's just 16, and then minus. And let's multiply these three numbers together. 4 times 3 is 12, and 12 times negative 7 is negative 84. So you have this double negative here. All over on the bottom here, you have 2 times 3, which is 6. So now simplify again. We have this negative 4 out front still. Underneath the square root, we can simplify this 16 minus negative 84. That double negative turns into positives, and then 16 plus 84 is 100. What is the square root of 100? That is 10. So now we can separate this into negative 4 plus 10 over 6 and negative 4 minus 10 over 6. I would recommend doing this by hand because if you put this into your calculator as negative 4 plus 10 and then divided by 6, what your calculator is going to do is use PEMDAS, and PEMDAS says do division first. So your calculator is going to do this first and then do the negative 4 plus after, which will be incorrect. We want to do negative 4 plus 10 first. So I'm going to do it by hand. Negative 4 plus 10 is 6. And then 6 divided by 6 is 1. So that's one of our answers. Negative 4 minus 10 is negative 14 over 6. If I keep this as a fraction but reduce it, I get negative 7/3. Okay, and there are our two solutions for part A. Part B wants us to solve by factoring, and it doesn't say here, but using the zero product property. So when we want to factor, we need the generic rectangle and the diamond. We always put x squared in the lower left corner of the rectangle, and we put the constant term in the upper right corner, and then we multiply these two terms to get the top of the diamond. X squared times negative 18 is just negative 18x squared, and then this x term, including that negative sign in front, is on the bottom of the diamond. And now we've got to figure out what are two x terms where the numbers add to negative 3, and multiplied to negative 18, and those two numbers would be negative 6 and positive 3. Negative 6 times 3 is negative 18, and negative 6 plus 3 is negative 3. So put those terms back into your generic rectangle, and now we can find the length and the width of this rectangle. So we can rewrite our original equation as now x plus 3 times x minus 6 equals 0. And now what the zero product property tells us is that we can take these factors and set them equal to 0. We can take x plus 3, set it equal to 0, and solve for x. If you subtract 3 from both sides, you get x is equal to negative 3. That's one of your solutions. Take the other factor, set it equal to 0 also, x minus 6 equals 0, solve for x. If you add 6 to both sides, you get x equals 6. And there are our two solutions. Okay, part C, we want to complete the square. Here's our equation. Remember that for completing the square, we like to start off by subtracting this constant term over to the other side. So that term that's at the end there, do the opposite to it so that it's on the other side. So now you have x squared plus 4x equals negative 1. And I'm leaving that space here because I want to complete the square. And I know I'm going to have to add a term to do so. So draw a square, put the x squared term down here, and then take this x term and split it in half. Half of 4x is 2x, so we put a 2x here and a 2x here, and now we can find the length and width of the square. We should have the same length and width because it's a square, x plus 2, x plus 2. So what do we add here to complete the square? Well, we do 2 times 2, which is 4. So that 4, we add to our equation, we add here, and whatever we add to the left side of an equation, we have to add to the right side. So now simplify. On the right side of this equation, negative 1 plus 4 is 3. On the left side of the equation, we can rewrite this sum as a product. Okay, length times width. Here we have the same length and width, x plus 2 times x plus 2. So that means that we can write that as x plus 2 squared. How do we solve for x from here? Well, how do you undo a square? How do you undo that exponent? You can take the square root, okay? Because your square root and your exponent cancel, you're left with x plus 2 equals plus or minus the square root of 3. Why do I put plus or minus? Because when you take the square root like this, you can have a positive or a negative answer. For example, if instead of the square root of 3, this were the square root of 9, then we would rewrite that as plus or minus 3 because positive 3 squared is equal to 9, but also negative 3 squared is also equal to 9. That's why we have that plus minus. We still need to get x by itself, so subtract 2 from both sides, and that gives us x equals negative 2, because of that negative 2 that we subtracted over, plus or minus the square root of 3. We could stop here if we wanted to, if they were asking for exact form. But let's keep going and let's find the answer in approximate decimal form to practice that, since we didn't have to calculate any square roots so far. So let's take that over here. What we would do is calculate that square root of 3 and round. The square root of 3 is, let's see, according to my calculator, it's 1.73205008 and a bunch of other numbers after. So let's just round to the nearest tenths place, 1.7. And then we would split this up because of that plus minus. We would do once, do addition once, so -2 plus 1.7, and then do subtraction once, -2 minus 1.7. So our solutions would be approximately -0.3 and -3.7. And again, these would be in approximate decimal form. Okay, last but not least, we have using a graph. What this means is that we want to draw a sketch of the graph. And then figure out where the graph is crossing the x-axis. So let's do this. Let's make an XY table. Let's include some negative values for x and some positive values so we get a full picture of the graph. And then the way that we're going to get these y values is by plugging in x into this equation. And once we have enough points to plot, then we can graph. So for example, if you plug in -3 in for x, you're going to get, let's see, instead of 2x squared plus 5x minus 12, you'd have 2 times 3 squared plus 5 times, the negative. -3 minus 12. -3 squared is 9. Okay. 2 times 9 is 18. 18 minus 15 minus 12 would be, 18 minus 15 would be 3, and then 3 minus 12 would be -9. So this -9 would go here. Let's practice that again by plugging in -2. I'm going to erase the graph because it's kind of in the way right now. -2, -2. -2 squared is +4, and +4 times 2 is 8. 5 times -2 is -10. 8 minus 10 is -2. -2 minus 12 is -14. So that would give us this y value. If you keep going, you're going to get -15 when you plug in -1. When you plug in 0 for x, you're going to get -12. When you plug in 1 for x, you're going to get -5. And when you plug in 2 for x, you're going to get 6. 3 is going to give you 21. And I think these are enough points to graph. We'll scale the x-axis by 1s. 1, 2, 3, 4, -5. And we'll scale the y-axis by, let's do by 2s. 2, 4, 6, 8, 10. 2, 4, 6, 8, 20. 2, 4, 6, 8, 10. 2, 4, 6, 8, 20. Okay, so our first point would be -3, -9, which would be about here. -2, -14 would be about here. -1, -15, 0, -12, 1, -5, 2, 6, 3, 21. Oops. And we would connect these points, but I don't know where to plot a point on this side. So let's add another value to my table. Let's add -4 up here so we can get another point to graph. If I plug in -4 in for x, let's see, -4 squared is 16, and 2 times 16 is 32. 32 plus -20 is 12, and 12 minus 12 is 0. That's perfect. So we can plot the point -4, 0, and there's our graph. It's okay that it's a little lopsided. I could keep going upwards, but what I want to focus on is where are my x-intercepts? My x-intercepts seem to be here at 1.5 and also here at -4. Okay? And that's exactly what those values are. So whenever you plot a graph of a quadratic equation, the x-intercepts will give you the roots of the equation. And that's it.